video over our test review problems for function graphs specifically. For problem number 1, it asks what is the rate of change of the graph. When you're given a graph and you're asked to find the rate of change, we want to pick out 2 points that we can read clearly. And so we can read clearly this point down here at -2 and 1, and we can also find this point here at 3 and +2. So when we write our rate of change, we write it as a fraction, the change in y over the change in x, also called the rise over the run. And so we go up 4 and over 2. And so our fraction becomes 4 over 2. But we always simplify our fraction. 4 divided by 2 is 2, which would be our final rate of change. For number 2, the question asks what is the rate of change of the graph. So again, we're going to pick out 2 points that we can read clearly. It can be any 2 points on the graph. They should all give us the same answer. I'm going to pick this point here at -6, and I'm also going to pick the point here at -1. Remember, when we write our fraction, we write it as a change in y over the change in x, also called the rise over run. To connect the 2 points, I have to go down 1, 2, 3, 4. So that would be a -4 because we're going down. And then over 1, 2, 3, 4, 5. Normally we would simplify all of our fractions. We cannot simplify -4 over 5, and so our rate of change will stay the fraction, -4 over 5. For number 3, it asks what is the slope of the graph. Again, to find the slope, we're going to pick out 2 points that we can read clearly. I'm going to pick out this point here at 4, and again this one here at 8. We set up our fraction as a change in y over the change in x, also called the rise over the run. To connect our 2 points, I have to go up 1, 2, 3, so that would be a +3 on top, and then over 1, 2, 3, 4, so 4 on the bottom. We cannot simplify the fraction 3 over 4, so the slope stays that fraction 3/4. For number 4, it asks what is the slope of the graph. Because our line is not going up or down, it is going straight across. It means that we cannot have a rise over the run because the graph is not rising. It's not going up, it's not going down, it's just going across, meaning our answer is simply 0. Our rate of change is our slope, m, is 0. For number 5, it asks what is the rate of change of the graph. When you have a vertical line, all vertical lines, no matter where they are on the graph, have an undefined slope. They can be located anywhere on the graph, but if it is a straight vertical line, it is an undefined rate of change, an undefined slope. For number 6, it asks what is the initial value of the graph. Initial value is represented by the letter b in the equation y equals mx plus b. B always starts at 0. 0 is at our point here in the middle of the graph, and so we want to look and see where does the line cross. The line crosses here at -3, and so our initial value is going to be -3. For number 7, again looking for the initial value, we look to 0. 0 is here in the middle, and we look to see where the line crosses. The line crosses here at +6, and so our initial value is +6. For number 8, what is the y-intercept of the graph? Again, y-intercept and initial value are the same thing. They're represented by the letter b. So again, to find b, we look at 0 here in the middle and find where does it cross. It crosses with 0 here at the -2 marker, and so -2 is our y-intercept. For number 9, it asks what is the y-intercept of the graph. Again, y-intercept is represented by the letter b. We always look to 0, and we can see that our blue line actually crosses at 0. So our slope, our y-intercept, our initial value, b, is 0. For number 10, what is the initial value of the graph? Again, we're looking for the letter b. B always starts at 0, and we want to see where the line crosses 0, and it's paired up with the +2. So our initial value, the y-intercept b, is +2. For number 11, it asks, what is the equation for the graph? Now remember, we want our equation to be represented in the form of y equals mx plus b. So to find our rate of change, the m, we've got to connect our points, picking out any 2 points that we can read clearly. I'm going to pick out these 2 points here. We label our rate of change as a fraction, the change in y over the change in x, or called the rise over the run. So to connect the 2 points, we have to go up 1, 2, 3, 4, 5, and then over 1, 2, 3. We always simplify our fraction. We cannot solve 5 divided by 3, so our rate of change m will stay the fraction 5/3. Now to find the initial value, the b value, we look to 0 and see where does the line cross. The line crosses 0 down at -5. So we're going to use all of that information to write our answer. Y equals 5 over 3x, because m and x always go together, and then the -5 at the end, because it's a plus b value at the end. For number 12, writing the equation of the graph, we're going to write it in slope-intercept form, y equals mx plus b. Starting with the rate of change, we write it as a fraction, the change in y over the change in x, or called the rise over the run. Picking out 2 points that we can read clearly, we're going to connect our dots. We have to go down 1, so down would be a negative, and then we go right 2. Because we have a -1/2, that is going to be our rate of change, our slope. Our initial value starts at 0, and we see where does it cross the y-axis. It crosses down at -8, and so we use those 2 pieces of information to make our equation. Y equals -1/2x, because m and x always go together, and then the -8 at the end for the b value. For number 13, we're going to write the equation of the graph in slope-intercept form, y equals mx plus b. Remember, the rate of change, the slope, is always set up as a fraction, the change in y over the change in x, or called the rise over the run. Picking out 2 points that we can read clearly, we can read this one up here, and we can read this one here down at the bottom. To connect our 2 points, we have to go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that would become a -10. And then we go to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then we want to simplify our fraction. 10 and 12 are both even, which means we can divide them by 2. -10 divided by 2 is -5. 12 divided by 2 is 6. Our rate of change is going to be the fraction -5/6. To find the initial value, we're looking at 0, the y-intercept, and so we want to see where the line crosses. The line crosses the y-axis at +6. So we use that information to make our equation. Y equals -5 over 6x, because m and x always go together, and then +6 at the end, representing the plus b value. For number 14, it says, what is the equation for the graph? We're going to write the equation in slope-intercept form, y equals mx plus b. When you have a straight horizontal line, your rate of change is 0, because the line does not go up, the line does not go down, it's just straight across, so it's a 0. To find the initial value, the y-intercept, we're going to look at 0 and see where the line crosses. The line crosses at +7. Using that information to write our equation, we would write our equation as y equals 0x, because m and x always go together, and then the plus b, the +7 at the end. However, zeros are not important, and we do not need to write zeros in our equation, so we can take out the 0x piece, leaving only y equals 7 for our equation. For number 15, we're going to write the equation for the graph. We would normally write our equation in slope-intercept form, y equals mx plus b, but when you have a vertical line straight up and down, a vertical line means you have an undefined slope, meaning you have an unsolvable line, meaning the equation cannot be written in slope-intercept form. Instead, we use the equation for an x equals equation, and x equals, looking at the number where it crosses, x equals +2. that would be our final equation answer. For number 16, is the graph linear or nonlinear? Remember, linear means straight line, nonlinear means not a straight line. This picture is not a straight line, so it is nonlinear. Number 17, is the graph linear or nonlinear? The straight line goes all the way across the page. It does not have any bumps, curves, or stoppages, and so this is a linear graph. It is a straight line. Number 18, is the graph linear or nonlinear? This graph is nonlinear because there are several curves up and down. It is not perfectly straight the entire time, so it is nonlinear. Number 19, is the graph linear or nonlinear? Even though the graph is made up of two straight lines, we have one going down and then we have another that bends and it goes up, it is not one giant straight line. So because of that, it is nonlinear. Number 20, is the graph linear or nonlinear? The graph goes all the way across the page. There are no bumps, curves, or stoppages, and so this is a linear graph.